When dealing with a lot of engineering filaments, a word you're going to see often is annealing. Annealing basically is a post-processing that you do with parts that you print out of engineering materials, where you take them and you basically bake them at a certain temperature to allow them to form crystalline structures, and it increases the heat deflection temperature and the overall rigidity of the part, making them a lot stronger. It really only works with engineering materials that are semi-crystalline or crystalline. If they're non-crystalline, annealing doesn't really do a whole lot. But you can see the bottom part is one that has not been annealed yet, and then the top one has been annealed, so you see a little bit of a color change. And the part itself is going to be much stronger, this top one here. My process for annealing is basically in this container here. I have a bunch of what's called popcorn salt. It's like a really, really fine salt. And what that does is I put the part in here, I fully submerge it. It secures it and prevents it from warping. What people suggest is when you put a part into popcorn salt like this, or any other material that you're annealing in, you press it down as well, compact it so that there's not any room for things to move around. Yeah, anyways, I submerge it in this container. This is a small little paint can that you can buy on Amazon for not very much money. This lid just goes on top. And then the popcorn salt you can find most grocery stores. But I put the parts in here, load it up, close it, and then put it in the oven at 200 degrees for my material, because I'm using PPA carbon fiber. You can see it says here the post-processing annealing guide right here. Temperature 80 to 100 degrees Celsius. 100 degrees Celsius is about 200 degrees Fahrenheit. About 212, but I just do 200 for 48 hours, and you just let it bake in there. And then when you're finished up, you just take the container, set it out, and let it be until it cools completely to room temperature. And that will allow the crystals, or the crystal structures inside of this thermoplastic to form, making it a really strong part that can support a ton of weight.